There was the sniff instead of the cough. What is with this record button and its triggers? Second good morning on a Wednesday. Trying to focus on what the topic is. I mentioned before precursor chemicals. So this is a whole rather hidden industry. It is the middleman section between the plastic you use and where it's made. So again, all of my legal commitments have cleared. Actually, decades ago, if I can remember anything about them. So here goes one. First chemical plant I worked at, the major one, really the only one. The rest I was a seagull at for instrument stuff, 2 or 3 days at a time. So this is one I worked in. Here's basically what we did. Orthoxylene. That is a chemical compound that very basically blows up in contact with air, which means it has a short half-life. I say that comically, but orthoxylene, if I've done my homework correctly, came out of rocket fuel research. This would be one of the most dangerous rocket fuels that we tried to play with on the list of many. So what this factory did was took a high purity orthoxylene flow from another plant miles down the road. That orthoxylene was pumped to our plant through pipes that ran along parts of the ship channel in Texas. And we fed it into an exothermic reactor, which means it generates massive amounts of heat. So if you chase the chemistry of orthoxylene out, you can find out why that's true. Okay, this exothermic reactor, I don't remember the skin temperatures, but my instruments measured the skin all around that reactor. So orthoxylene and some fixed amount, a ratio of air is put together, and basically it explodes. That's the beginning of heating up the chamber for the orthoxylene to actually get into a reaction status. So to start this thing up, you spend days heating the vessels up with natural gas, propane, and what you're trying to do is absolutely dry all the refractory materials out. The inside of that stainless steel vessel is lined with feet of refractory material to keep the heat from getting to the steel, because the heat will melt the steel, period. So especially after first setup, the whole reactor interior has to be cured. So it's basically made into a kiln for so many days to cure out slowly and let it expand and, do its final meld together during that thermal expansion process. Now that you've got it hot enough, well, going to back up a little bit. I said this was an exothermic reactor, so it had to be cooled. We drew 600 pounds steam off of the reactor, so we put cold water in the bottom of the skin of the reactor and 600 pounds steam came out of the top of it, and we fed it further down the process, and it fed a whole nother plant with preheating steam. So if this plant was running, it could preheat or add heat into other parts of a process. It was a separate physical plant, but you share utilities. So you spent days running natural gas through this reactor. You have used that heat to heat up a mile of process stream that's going to be needed to take care of what the product out of the reactor is. So you're pumping orthoxylene into the reactor very slowly first. You just came off of a propane methane burn heat cycle. You've got the reactor coolant system up to an operating temperature, not running, it's operating now. The coolant system is comprised of tubes filled with salt and just a little bit of water. So this is liquid salt cooling for 600-pound thermal steam transfer. Liquid salt is very abrasive, so it takes some very, very good materials and monitoring to watch that abrasion doesn't affect your reactor vessel cooling system. So now you've got a reactor fired up and you've got a temperature balance. You're trying to keep internal reactor temperature, a few thermocouples watching that, or devices, and then reactor skin temperature, so that you don't overheat an area. If your flame is not shaped correctly inside the reactor, you can overheat sections of it. So you are trying to watch temperatures across the whole reactor skin. Only that instrument had a bug in it for a year and a half until I convinced folks where it was and got it fixed. But I was still using the data, and engineers were still using the data. It's just when it was bad, it was bad. So when it was good, it was valuable data. So now I've got an exothermic reactor. If you know 600 pounds steam, it's 400 something degrees. Very hot. You have a leak in a 600-pound steam pipe, it will cut you like a saw. If you've seen, water jets cutting, that's what 600-pound steam is equivalent to if you have a pinhole leak. So we've got an input of orthoxylene, which is a former rocket fuel developed for one of the space program tests. And the reason it failed is because what its output is plastic. Orthoxylene, simply put, turns into phthalic anhydride, which is a plasticizer, which is one of those precursor chemicals. So this plastic makes other plastic better. Or this plastic in its pure form, phthalic anhydride, has some special properties you might want to use somewhere else in something because of something. So phthalic anhydride is a word you can find. Orthoxylene is a lot harder to find. The MSDS sheets point to a lot of it. If you go to chemical, more chemistry, it simply put is dynamite. Only the output of it is plastic. So after your rocket goes off, everything nearby is coated in plastic. Everything, that whole rocket tail is plastic. The plume coming off of it is just a light dusting of microplastic particles. So somebody figured that out and decided we won't talk about that for rocket fuel. If you go look at some of the racing gas treatments, orthoxylene is an additive, very, very low percent additive, because it plastics up the inside of your engine, but it explodes way cool when exposed to air. So you can dissolve it in gasoline, and it will go mix and disperse nicely, but the vapor pressure of the gasoline just went up a little bit, the explosive content went up a little bit, and your pistons pop a little bit better when you add that as a fuel in. But the cost of running that plastic into your motor and it coats everything, it destroys catalytic converters, or it gets further taken apart, or the phthalic anhydride can get destroyed by a catalytic converter, which we had in the process, huge ones you could walk in. And that was what took care of the gas going to the emergency exhaust stacks. So if we had to burn off masses of plastic, there were huge catalytic incinerators sitting there on hot standby, or actually being used, because they did work very well. So a little bit of process waste had to be processed when you're doing switch condenser tank. So yeah. Now if that process had a leak in one of the phthalic anhydride line, or in the PA lines, the output of that reactor. Now remind you, this reactor is 6 stories tall. It is mechanically designed, if it gets overpressured, that the lid blows off of it, so it doesn't blow up sideways. I've mentioned this in other conversations about this process. So you explode orthoxylene, you burn it like a rocket inside a container, and you extract the plastic out of it that's made using switch condensers, which are like cooling and heating cycle devices that will condense the plastic back into a plastic from a gas. And then they switch all their valves around, they melt that plastic back off the condenser coils, and it drips down to the bottom of the tank and is put off into product tanks. And off the top, the gas is recycled back around, and then eventually as much is pulled out. It's a long story, kind of long process. Those switch condensers can be used in kind of some recovery ways, or they can just be used in a flat out make plastic way. So depending on what your process is trying to balance for, say exhaust stream output versus production output, you can do some tuning and balancing. And somewhere there's an EPA guideline or rule that says what really can come out of that stack. It's probably in some contract, some EPA document filing that went to the state's zoning board, that the state zoning board approved for energy. And do they know enough? And is that board, Oregon's got a problem with this because of corporate secrecy and patents. So what was I talking about? So these precursor chemicals, in your spare time, go do a Google Earth of the Houston ship channel from the city of Houston through the port of Houston out into the Gulf. And when you get there, take a right or a left. Pretend you're on an airplane ride going across the beaches there. As you go down, you'll find, if you took a right, you're heading south, right? You're going down, you're going to see miles and miles of beautiful beaches, in between miles and miles of chemical facilities that supply products to the globe. If you took a left out of the Houston ship channel, you'd be heading towards Louisiana, more bayou and swamp countries, and you'd see more chemical plants. And those tend to be more hidden back in the bayous, because where you have water to do things is where you want to do them. And if you don't want people to see what you're doing, or you got the 1,000 acres you needed for really cheap because it's back in a swamp, well, there you go. There's a new chemical plant. I was invited to work at a couple of them when I had a contract opening. So I know where they are. Didn't go, well, I did visit one, different life. So this is heavy industry. This is large chemical plants. This is done with federal subsidies, with tax dollars. It helps the city out. It might pollute the city and 40 miles around it. And hopefully we'll figure that out before the damage is done. What this means in the real world is lawyers have to get involved. And litigation after the fact means you're arguing over dead bodies. And somehow we're better than that. So this is the Wednesday longer ramble. Please comment, like, recommend, subscribe. The conversations are pretty consistent. At least the tone of them is. Try not to blame. Try to understand and figure out how to make it work. Because I want my grandson to go see Yosemite before it's fracked. Or maybe it never should be fracked. We can do better. Peace, love, hippie stuff, communist quotes, right-wing sayings, blessings, good health care to you, and whatever good days are coming up. Vote. All right, there it is. Vote. Vote. Could have said that in 30 seconds.